And now we'll see about the unit 4 short answers questions. So the first question is define random process. A random process is a family of functions where x less than or equal to x of t comma s, where s belongs to capital S and t belongs to capital T. Okay, defined with random variables x less than or equal to x and sample space S and with function of time t. So thus we can say that as a random process is a function of two random variables. Random process is function of two random variables, sample space and time. Okay, so x less than or equal to x, that is a random variables. So it is a function of t comma s, where s is a small s is function of belongs to capital S and small t belongs to capital T. Classify random process. Random process can be classified as continuous random process, discrete random process, and continuous random sequence and discrete random sequence. So in continuous, while coming to the definitions of the continuous random process, in continuous random process, so if we see, we're having x of t comma s, continuous random process. A continuous random process means both random variable x and time are continuous. So both x, random variable x and t are continuous. Discrete random process means the random variable x has discrete values. X is discrete and t is continuous. Okay, process. And sequence means, remember, whenever it comes a sequence, t is discrete. Continuous random sequence means x is continuous and t is discrete. Okay, and discrete random sequence means both x and t are discrete. Okay, so these are the classifications of random process. The right formula for the cross correlation function of two random processes x of t and y of t. So cross correlation can be represented with r xy of tau is equal to expected value of x of t, y of t plus tau. Okay, that is the formula for the cross correlation function of two random variables. Autocorrelation function means over x of tau is equal to expected value of x of t, x of t plus tau. Next, when can we say random process is stationary? Stationary process, a random process is said to be stationary if all its statistical properties such as mean, moments, variance, etc. do not change with time. So outline the conditions for a process to be a first order stationary random process. A random process is said to be first order if its first order density function does not change with time. First order density function means fx of x1 colon t1 is equal to, this is the first order density function of the random process x of t, does not change with the time means even though if you replace t1 with another value colon x, t1 with delta t, okay, for any value of t, for any t1, you can say this is a first order density function does not change with the time means x1 colon t1 can be written as x1 colon t1 plus delta t. So here t1 is replaced with t1 plus delta t, and there won't be any change. Okay, so the conditions is e of x of t, that is the expected value of the random process, is equal to x bar, that is equal to constant. Okay, e of x of t is equal to x bar, that is constant. Outline the conditions for a process to be second order stationary random process. Second order random process is the if its second order density function does not change with the time. Second order density function means fx of x1 comma x2 colon t1 comma t2 is equal to fx of previously we wrote only t1. Now we are writing t1 plus delta t comma t2 plus delta t. Meaning that second order density function does not change with the time for all values of t1 and t2. Conditions are the autocorrelation function, that is Rxx of t1 comma t1 plus tau is equal to Rxx of tau. t1 comma t1 plus tau is equal to Rxx of tau. That is Rxx of should be independent of time t. Rxx of tau should be independent of time t and function of tau only. Function of tau only. Okay, first try the second order. The process is to be second order stationary if second order density function does not change with the time. Write this formula and then write the condition. Okay, next outline the conditions for a process to be wide and stationary random process. The conditions are first two. So write the two conditions. E of x bar x of t, E of x is that is E of x of t is equal to x bar, that is constant, and the second one is the autocorrelation function does not change with it, that is the Rxx of tau, that is E of x of t, x of t plus tau is independent of time t, function of tau only. Writing both the conditions. First order stationary E of x of t is equal to x bar, and second order stationary Rxx of tau. Write the two conditions, then it is wide and stationary random process. Next, list out the conditions for a process to be jointly wide sense. So first one, jointly wide sense means two random processes. So E of x of t is equal to constant, and the second is E of y of t is constant. Two random process, both the mean values are constant, and we need to write, previously we wrote the autocorrelation function, now we'll write the Rxy of tau. Rxy of tau, that is expected value of x of t, y of t plus tau is independent of time t, function of tau only. Okay, so this is the conditions for a jointly wide sense stationary. These are the conditions for a process to be strict sense stationary. A random process is said to be strict sense stationary if its nth order joint density function does not change with the nth order means fx. So second order means we wrote only x1, x2. Now it is nth order. We'll write xn colon t1 comma t2 and so on up to tn is equal to fx of x1 comma x2 and so on xn comma colon t1 plus delta t, t2 plus delta t and so on tn plus delta t. That is the nth order density function does not change with the time. Then we can say it as a strict sense stationary for all values of t1, t2, t3 and so on up to tn. Okay. When two random processes are said to be independent, two random processes assume that we are having x of t and y of t. These are the two random processes. Random process always x is the capital and t is the small. You should be remember. Then the joint, previously if you remember, independent means E of x, y, fx of x comma y joint density function is equal to the product of the individual density function. If you remember, we wrote like that, fx of y x comma y is equal to fx of x into fy of y is equal to the same formula here will write f x y of this is the random process, that's why you need to write x1 comma x2 and so on xn colon y1 y2 and so on up to yn semicolon t1 comma t2 and so on up to tn comma t1 dash t2 dash and so on up to tn dash is equal to two random. That's why x1 x2 x3 up to xn y1 y2 up to yn. For x values t1 t2 tn, for y values t1 dash t2 dash tn dash and so on is equal to the, this is the joint density function of the two random process, is equal to the individual density function fx of x1 x2 and so on xn semicolon t1 t2 and so on up to tn into fy of y1 y2 and so on yn semicolon t1 dash t2 dash and so on up to tn dash. So this is two random process said to be independent. The joint density function of two random process is equal to the individual density functions of the random process x and y. That is the nth order density functions. Define time average function. Time average. So write the directly formula. Time average can be represented as x bar, that is the a of x of t. A of x of t. Formula is time average of the random process. So we'll write it as limit t tends to infinity 1 by 2t minus t to t x of t dt. So this is the formula for the time average of the function. The time, that is the average value of x of t taken over all times, is called the time average of x of t. Okay, the average value of x of t, average value of x of t taken over all times is called the time average of x. Time average of x of t. It is also called as mean of x of t. Okay. Next, define ergodic theorem. So ergodic theorem states that for any random process x of t, all the time averages of the sample functions of x of t are is equal to the corresponding statistical or ensemble averages of x of t. That is, this is time average is equal to the ensemble or the capital X bar, that is the expected value of the random variable. Small x bar is the time average, and you can write it as r xx of tau is equal to rxx of this is called the time average of the autocorrelation function, time average autocorrelation function. This is the time, this is the autocorrelation. Time autocorrelation function is equal to the autocorrelation function. Okay, so then that is the statistical is equal to the ensemble average of x of t. Ergodic process, a random process that satisfies ergodic theorem are called the ergodic processes. Jointly ergodic process means if two random process, that is the x bar is equal to x bar, y small y bar is equal to capital Y bar, and here we will write it as rxy of tau, that is the time cross correlation is equal to the cross correlation function. Okay, rxy of tau is equal to, then we can say it as a jointly ergodic. Then mean ergodic is called E of x of t is equal to x bar, that is equal to A of x of t, that is equal to small x bar. Mean ergodic, mean A of x of t capital X bar is equal to small x bar. Okay, then autocorrelation ergodic is capital rxx of tau is equal to rxx of tau. that is time autocorrelation function is equal to the autocorrelation function, that is A of x of t plus tau is equal to the expected value of x of t plus tau. Okay, then cross correlation means Rxy of tau is equal to Rxy of, that is time cross correlation function is equal to the cross correlation function, that is E of x of t y of t plus tau is equal to the E of x of t y of t plus tau. Okay, then they may ask like this, they may give some of the properties regarding like autocorrelation or cross correlation, and they will ask you to prove this one. So Rxy of tau is equal to Ryx of tau, that is minus tau. Okay, this property, go and search the properties of the cross correlation function, and this type of question they may ask. And Rxx of minus tau is equal to Rx. This is one of the property of the autocorrelation function. And one more property, that is the first property, E of x square of t. E of x square of t is Rxx of 0. This is also equal to the power of the random process. Power of the random process x of t, or average value of the mean square value of x of t. Okay, mean square value of x of t. So they may ask anything. Okay, sometimes they will give Rxx of tau, and they will ask you to calculate the power of x of t for 1 mark. Also they may ask that type of problems also. Okay, Rxx of tau they will give it as a equation, and they will ask you to calculate the power of the x of t. Just to substitute tau is equal to 0 in that expression, you will get the power of the x of t. Otherwise mean square value of x of t, anything. So properties of the autocorrelation function, properties of the cross correlation function are very important. Okay, go through those two videos. You can, they may ask any thing for your 1 mark question also. Okay, next define autocovariance and cross covariance functions. Autocovariance is Cxx of t comma t plus tau is equal to E of x of t minus E of x of t E of x of t into x of t plus tau minus E of x of t plus tau. Okay, so this is the autocovariance. Cross covariance means you replace with the xy of t comma t plus tau is equal to, that is E of x of t y of E of x of t minus E of x of t into y, in place of here x you write y of t plus tau minus E of y of t plus tau. Okay, that is about the cross covariance and the autocovariance. Okay, sometimes they will ask one more questions, that is the correlation coefficient. Okay, write about the correlation coefficient also. That is, if you remember the third in formulas, you can write these formulas. Yeah, but replace x with the, so there you are writing E of covariance is equal to E of x minus E of x bar, that is x bar, E of x minus x bar. Now we are writing x of t minus E of x of t. Okay, that's